Hello, I'm Dr. Brian Fraser, and in this video I'm going to cover some of the very basics of a C program. This is predicated on the idea that you've already got an understanding of how to program in another language, and this will introduce fairly quickly some of the basics of a C program. Look at a previous video on how to get started with Eclipse into Linux to get to where I'm at in the start of this demo. So to begin with, a C program starts in the main function. The general prototype of a main is it returns an int, and down here I'm returning that value. A 0 indicates to the operating system that it's succeeded, so you just put the 0 in here. The two arguments, we have the count of how many arguments are being passed in. These are known as the command line arguments, and then we actually access them through this, which is a little bit confusing, but it's a pointer to a pointer, or pointer to a character pointer, which is actually a pointer to a string. So in fact we've got an array of strings that were being passed. So we'll look at what those are as well. So to begin with, if we look at the basic structure, we come in at main. The way we access the screen is through a printf command, which is print formatted, and we pass it in. We can pass it in just a straight string here, but we can also pass it in some arguments. So let's look at what those could be. So let's first off create a few variables. I'm going to create an integer height. I'm going to create a character string, so that's a char star. Let's call it name, and I'm going to start off with the name of Bubba. And let's create a long, this is going to be on my system, a 64-bit variable. And let's call it favnum for the favorite number, and let's make that 42 just for fun. And let's put in a float as well, and let's make that weight equals 77.8. Sounds good. Actually, I'm going to do 0.2. That should be fine. One thing I want to actually show here is how to do a long. So let's make this, instead of being that, let's make it a very big number. I think that's long enough. At the moment, it's not going to work under the C spec, I believe, because it treats this number as an int. So instead, we want to treat it as a long. So put LL at the end, and that forces the constant to be a long. So let's start printing these out to the screen. So under Eclipse, I'm going to go Control-Alt down to duplicate the line of code that I was on. And I'm just going to say here, so let's do int. And to print something as an int, I need to use the %d. And here I'm going to write out height. I'm going to duplicate this line. Let's write out a string, so char star. This text at the front is simply there to show us on the output. %s is for a character string. This is expecting a null terminated array of strings, or of characters, pardon me. So I'm going to put a name here. I'm then going to print out my favnum, which is the long. To do this, I need an LLD, and that's going to be favnum. And finally, I've got the float, and that's going to be %f. And that's my weight. I'll save that. Save that. Build it. And in my make file, which I've got loaded here, make all builds not only my hello program, but it also runs the test on that. And my test is just to execute the hello world function, or pardon me, executable. So down here in the output, we can see that it went ahead and built it down to here, and then executed it. So this is the output of my program: the int, the string, the long, and float. Now float looks kind of funny. Ask, why did it give me this? Well, you cannot represent 77.2 in a floating point number. If I switch this to a double, wouldn't really help, because it's trying to express the fractional portion as sort of a power series of 1/2, a fourth, an eighth, and so forth down the line, and you can't express 0.2 exactly. So instead, we might want to say, well, let's not print this out like that. I want to print it out maybe rounded to 2 decimal places. So I'll duplicate the line, and I'll print it, so float to 2 decimal places. I can here put in a .2, and that will force the output to round to 2 decimal places. So let me rebuild that, and here we have it correctly rounded to 2 decimal places. So that's kind of nice. A couple of things I can do. I can print out as in hex. So printf, and I'm going to print out in hex. and that's %x/n for the line feed, otherwise it'll print it on the same line. And let's print out the height. I need an integer for this. Print out the height in hex. Rebuild that, and it prints out just A. Of course, 10 is A in hex. One thing I'll often do on something like this is to show to the user that it's hex, I'll type an OX in front. So that just gets printed as straight text. And then when the user sees it, it looks just like it's hex. If you wanted it uppercase, instead of the lowercase a, I can make that a capital, so %X. Save that, rebuild it, and it comes up as uppercase. And then the one last thing I wanted to show here is if I wanted to use up a certain amount of space on the screen, I can do, let's do %D just to keep it simple. I can put like a 5 in front, and this will pad whatever I output to be at least 5 characters on the screen. It could be more, but it'll take up at least that amount of space. So I'll run it again, and here we can see that 10 takes up 5 characters on the screen. This is a fantastic way to format your output. Okay, so that kind of handles us going through some of the printf basics. Let's have a look at how to do a for loop. I mention this because if you're using state C, which is C89, the for loop has to look a bit different. So you might normally write a for loop. We've got it up here. Let me just create a new variable, int I. And then down here, I might have, let's do it right up here at the top just to keep it simple. For I equals 0, I less than height, I plus plus. And printf I equals %D. And I'm not going to put in the line feed here just so we can see what happens. Print that out, and at the end, printf/n. This will put it all on one line. So let me run that. Go back up here, and we can see it printed out all on one line. Now, one of the things that I'm doing is in my make file, I'm specifying the argument for C99. Let me get rid of that for a moment, and we can just see what happens. I'll comment that out. And if I go back into here, build, we're looking good. Now, the problem, or one thing I'd love to be able to do is get rid of this I definition here, and I'd like to be able to define I inside my for loop. So I'll say int here, get rid of the I definition there. And when I try to rebuild this, it says it can't. It's only allowed in C99 mode, or you can do it in the GNU mode. So instead, I'm just going to use C99 because it's a standard. And let's go back here, put in this option for -std equals C99, and now when it compiles my code, it's going to work just fine. Up here I get my loop as before. So that's what the one of the big values for me in C99 is I can start to put my variable declarations inside of my for loop. I'm going to comment this out here. Let's comment that out, and I'm going to come down here and comment all this out. Okay, one last thing that I wanted to, or a couple things I wanted to show in this. At the very top, we've got this hash include. This is how we allow ourselves access to other portions of the language beyond sort of the default stuff in the language. So, for example, printf is found in stdio.h. Standard lib defines a number of other standard features that we might want. One handy thing is instead of passing back this 0, I can pass back exit success. It just gives it a meaning, and that's defined in standard lib. So let me rebuild that. And here, oh, it's giving me some warnings that I've got these variables that I'm never using. I'm going to comment them out. I've told C to make it a error. So here I've got the W error flag. So anything that's a warning normally has become an error, so that I don't have these sort of pesky bugs in my code. Let me rerun that. We're looking good. So up here at the top, I'm just going to insert a, let's start running a function. So I might want to say compute a factorial. So I'm going to do printf, let's do 5 exclamation mark, which stands for 5 factorial, equals %d. And I'm going to create a function factorial, and I'm going to pass in 5. Of course, hard coding the numbers isn't great, but that'll do. So how do I write a function here? I'm going to make it return an int. I'm going to call it factorial. And I'm going to pass in an integer. So int, and let's call it n here. Oops, and conform to my own style guide. Now I can compute this in a recursive manner. Let's just do it in an iterative manner. So for int I equals 0, I less than n, I plus plus, and I'm going to have int result equals 1, and return result. So this is the basic structure. Now, of course, I actually want to start at 1. I want to be less than or equal to n, and result multiply equal by I. Now let's just check that. So I pass in n. My loop is going to go through from 1 to n, and so I'm going to multiply result by that. Really don't need to multiply it by 1, but easy for completeness. And let's see if that works. Let's do a quick test here. Let's do 3 factorial is going to give me 6. So let's just start with 3. A number I know to make sure it's working. There we go. 3 factorial is 6. It looks like 65 because, of course, I forgot the /n for the line feed. Fairly common error in my output. Okay, so that looks pretty good. So I've written a function here. I'm passing back a value. I'm using the value in line. I could have, of course, caught this into a variable. So I could say int 3 factorial. I can't do 3 factorial. I got to do factorial of 3. Can't start with a number. Equals that. And I can put it into here. And good enough. Rerun that, get the same answer. So I can catch it into a variable, or I can use it directly. Now the one funny thing about functions in C is I might like to have my main function listed first in my program. So I'm going to cut this. I'm going to come down here, I'm going to delete all this extra code that I didn't need from before, just to keep my functions or my program short. And I'm going to put my function here at the end. So all I've done, let's see if I can actually make this a bit clearer. There's my whole program. I moved my function to be after main. So I'll save that, build, and it didn't build. Why? If I scroll back up here, it says implicit declaration of function. Now this is actually a warning, but I've told it to treat it as an error. This is good because if it comes across a function it doesn't understand, doesn't know what it is yet, it will make certain assumptions about it. And if those assumptions happen to be incorrect, it can really cause some strange behavior. So what's really going on here is that C is doing a one pass through my file to compile it. And so it comes along, and by the time it hits this line of code, it has never heard of a function named factorial. That's defined later. So it has no idea. It starts to make assumptions about what's going on, which is hence this implicit declaration. So instead what I want to do is I want to let it know that this function exists. I can either move this whole implementation of the function above main, which in some cases works but maybe isn't a great style. If I want to have a better organization to my file, I'm going to put what is called a prototype. So prototypes. And here I've only got one function, so I copy this first line of the function, which is the return type, the name, and then the arguments, and I put a semicolon at the end indicating that it is just a prototype. I'm going to save it, rebuild, and now it builds correctly and executes as before. So that's how I work with the prototype in there. It allows me to reorder the code inside of my file. Okay, and then the one last thing I wanted to talk about, I think I've said that already, but let's actually do one more thing, is constants. So to put a constant in your code, inside of main for example, I can say create a constant for, let's do days of the week. So I can do this a few ways. I can first do hash define, which is a standard way in C. So let's do hash define days per week. And of course there's 7. Note that there is no equal sign here and no semicolon. That's a critical factor of hash define. I can create a constant in a variable, so int const int, and let's do this hours per day equals 60. If I'm doing a const int, it looks like sort of a normal variable. I just can't change it later. And I can do, for example, const int hours per week, which is going to be days per week. I'll do control space to autocomplete, multiplied by hours control space, and I can pick here hours per day. That looks pretty good. And let's print it out. Printf hours per week equals %d line feed. And hours per week, print it out. So when I run my code, you can see hours per week is 420. Okay, pretty believable. Now, It's kind of strange actually to have a hash define as a local. Hash defines this is a macro. So what happens is the preprocessor looks for all occurrences of the text days per week as tokens in the code, and it actually goes through and it replaces them before compiling with whatever's after it. So it does a straight text replacement, and so effectively it takes out this and puts in a 7. So that's the way the macro works. So generally we'd put that up here at the top under constants. And so again, this is going to work just fine. Now, some kind of weird things begin to happen. If I start to move all of these constants, I can move let me just do one of them first off. I can put this constant up here. I'm going to fix my indentation. And that's going to work too. I now have a global constant. Code executes fine. Gets a little funny though if I try to move this constant up. Try recompiling, it doesn't actually build. It tells me here initializer element is not constant. Because what this actually ends up looking like to the compiler is it replaces the macro with the 7, and that's good. But this hours per day, it thinks, well, that's a constant variable, and it can't figure that out as being a constant. C kind of has this notion of two different levels of constant, this being the second-class citizen. And you can't, as it turns out, have a global initialized to something that gets that is computed in this sense, or computed with another constant int, such as this. I can fix this by switching this to a hash define. Hash define is preprocessor. Got to get rid of the semicolon as well. Let me go back here to my days per week. Save that. And now when I compile, it'll compile fine, because the compiler ends up seeing a 7 here, a 60 here, and we're good to go. I guess, of course, actually, hours per day is going to be something more like 24. Minor point. Okay, so now we can do that, and that's okay. We compile it here. What if we wanted to end up using this in certain ways? For example, if we wanted to create an array, a local array, I can say int, let's call this, friends. We want a friend, and we want a friend per hour of the day in a week. So I can do hours per week. And this is going to create an array of integers of size, however many hours are in a week. So let me rebuild that. And here, it doesn't want to do that. Because, oh wait, the problem is we got the unused variable. So let me just actually use that variable. First friend. And maybe we've got friends as numbers, so let's just put that in here as friends sub 0. And rebuild. Okay, so that's fine. What if we wanted to make this a global? Now, of course, globals are often bad, but in some cases we might need it. We might want it as part of a module, which will be covered in a later video. So here, if I try to run this, it's not going to work either, because it wants to have variable modified friends at file scope, which is a complex way of saying you tried to create the array of friends, of integers, using a value that isn't actually this sort of first-class constant. It's a second-class constant, which is the const int we had here. So we can fix that again by using hash define, switching it to hash define. I don't want it to be equals this. I want to say it's multiplied. So this would work, although if you're familiar with hash defines, you almost always want to put brackets around anything that's at all an expression. So here I need the brackets, otherwise we can have big problems later. I'll rebuild this, and now all of a sudden C is happy. So a general piece of advice is hash defines can be a little dangerous if you're using them incorrectly. I try to go with const int if I can, but in a lot of cases you kind of have to revert to a hash define. It's an unfortunate thing, but you got to go with it. As one last freebie here, let's show you what can go wrong with a hash define. So I'm going to create the constant 2, and of course 2 is equal to 1 plus 1. So down here we can print out what is 2. Well, 2 is here, and if I run this, unsurprisingly, C is going to tell me that 2 is equal to 2. Now, we could ask, what is 4? So 4 is, of course, equal to 2 times 2. That looks pretty good. If I run this, we're expecting the number 4, and as it turns out, we get the number 3. It's even more crazy if I start to use here 2 is equal times 2. So, well, here we go, 4 is still 3. Now you can ask, what's really going on here? Why can't C do basic math? Well, it can. Remember what I said about expansion. C finds every occurrence of TWO and replaces it with this text. So let's try that manually here on this new line. I'm going to replace this with that. So this is what we actually get to the compiler. If you remember your precedence rules, multiplication happens before addition or subtraction. So we end up with 1 times 1, gives me 1. And then I'm going to add in a 1 and a 1. So I end up adding 3 ones together. So that's obviously not what we intended. What we intended to do was have brackets around this. I'll put brackets here. So 1 plus 1 times 1 plus 1. And that'll then give me the 4. So let me compile that. Save compile. Up here, 4, we get correct value here when I actually do the correct expansion. So the trick is to put brackets around expressions, or around your constants when you hash define something. And now I get the appropriate 4. Okay, so that's the quick summary of Crash Course on C programming. Thank you very much.